All right, welcome back. Last time we met, we were working on notes 4.3, more proofs. And I had left you in question 3, which number 1 was the first one that we worked the right instead of the left. And if I'm not mistaken, we had worked, don't worry about that, we had worked down to 1 plus tan squared plus 2 sine over cosine squared. All right. So we're going to pick up from there and see if we can make this look like 1 plus sine over 1 minus sine. So I'm using a separate sheet of paper because it's going to take me a little more room. And also, I want to keep my granddaddy identities off to the side where I can have easy reference to them. Okay, so that's where we are. We'll just set that aside. So right now I'm at 1 plus 2 tan squared plus 2 sine over cosine squared, and I left out the square. All right, so I've got to figure out a way to put all this together, because remember, our goal here is 1 plus sine over 1 minus sine. So what I know is that tan squared is sine squared over cosine squared. So I'm going to have 1 plus, because I'm going to change tangent into a fraction, I'm going to write 2 over 1, and I've got sine squared x over cosine squared x plus 2 sine x over cosine squared x. And by doing that, we've uncovered that we have common denominators on these two fractions. So now I'm going to add those fractions together, and I've got 2 sine squared x plus 2 sine x all over cosine squared x. All right, we're getting closer, but now we've got this 1, so we're going to do right to left, left to right, denominator, denominator. So now I've got cosine squared x plus 2 sine squared x plus 2 sine x all over cosine squared x. Well, now again, let's go back. We want everybody in terms of sine. So if I come up here to the granddaddy equation, I know cosine squared is 1 minus sine squared. Okay, I'm going to make that substitution in the denominator in a minute, but I'm going to make it in the numerator right now. So I'm going to replace this cosine squared x with 1 minus sine squared x plus 2 sine squared x plus 2 sine x all over cosine squared x. And you can make the substitution in the denominator right now. I just don't want to do that right yet. Now, what does that do in our numerator? Well, it gives me 1. I've got 2 sine squared x's here, and I'm subtracting 1, and then I've got sine squared. So I've got, in my numerator, I've got 1 sine squared x plus 2 sine x plus 1 over cosine squared x. So again, if you had, and I'm just going to write this in a different color, if you had x squared plus 2x plus 1, your immediate thought would be to factor that, right? Are there any factors of 1 that add to give you 2? Of course there are. You have x plus 1, x plus 1. Well, you're going to do that exact same thing here. You have sine squared plus 2 sine plus 1. So you can factor this. The rules are the same. And that's going to give you what? Sine x plus 1 times sine x plus 1. Think that through. Sine times sine, sine squared. There's 1 sine x, there's 2 sine x's, and there's the 1. And now, at this point, I'm going to make the substitution for the cosine squared. And I know that cosine squared is 1 minus sine squared x. And again, where do I get that? I get that right here from the granddaddy equation. So now things are looking much brighter because now I've got all sine, 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 which I need. And I'm looking for 1 plus sine over 1 minus sine. Well, I know, isn't this difference of squares? A squared minus b squared? Sure it is. So now in your numerator you have sine x plus 1, sine x plus 1 over 1 minus sine x, 1 plus sine x. And of course, these terms cancel out, and you're left with 1 plus sine x over 1 minus sine x, and that's where we were heading. My recommendation to you, look through what we've done, and then I would go back and rework that at least 2 more times to make sure you understand the flow of the problem and how it all stays together. All right, but we're going to move on to assignment 4.3 now. Let me get this out of the way and get the assignment up here. So the goal today is to get through assignment 4.3 and also to start the review. And then what I'm going to do is send you the test, and then I'll send you the key to the test, and you can ask your questions as you need to. All right, here we go. More proofs. Verify each identity. Again, granddaddy at the top. And there we go. Because we're going to refer to it a lot. I'm sure we are. I'm trying to make cosine over 1 minus sine squared x equal to secant. Okay. I can't change cosine, but I can change 1 minus sine squared x. So I've got cosine over cosine squared x, which gives me 1 over cosine x, right? One of those are going to cross out. And 1 over cosine x, of course, is secant x. Okay, try problem 2. We're trying to make sine squared over cosine look like tan sine. I'll put the answer and the directions up in just a second. And that's what we're going to do. We're going to be working back and forth across the page. Let's see how you did. I've got sine squared. You may have been tempted to say that's 1 minus cosine squared x. I'm not sure that would have helped you much at all. So all I did was broke this into sine times sine, which is sine squared over cosine, and then I separated the fractions. Sine over cosine times sine over 1. And there's your tan sine. All right, let's look on to number 3 here. Now we're trying to make sine squared times cosine times secant equal 1 minus cosine squared. Well, again, you should recognize pretty quickly cosine times secant is 1. So I've got sine squared x times 1 is 1 minus cosine squared x. And if you go look at the granddaddy equation, we are done. 1 minus cosine x squared x is sine squared x. Done and done. Okay, let's look at 4. No one is squared in 4. And what do we know secant is? 1 over cosine, and cosecant is 1 over sine. And then you've got 1 plus tangent. So I'm going to tell you right now, rational, rational, rational. Go ahead and work that, and I will put the answer up in just a moment. Okay, so I change secant to 1 over cosine. I change cosecant to 1 over sine, and I change tangent to sine over cosine. And then right to left, left to right, denominator, denominator. Right to left to right, denominator, denominator. And then I'm going to flip. So I've got sine plus cosine over cosine sine times cosine over cosine plus sine. Those cancel out. That cancels out. And you're left with 1 over sine or cosecant. All right, let's look at problem 5. Cosine squared minus sine squared x is 1 minus 2 sine squared x. All right, I need the sine to stay in the problem. The problem is I've got to get 2 of them somehow. But let's come up here and look at our granddaddy equation again. Cosine squared is 1 minus sine squared x. So I'm going to replace this cosine squared x with 1 minus sine squared x, and then just continue writing the equation. Oh, I've got 2 of the same term. 1 minus 2 sine squared x. Knowing that granddaddy equation is going to help you a lot. Okay, nothing squared in 6. And I can already tell I'm going to be introducing rationals here. Cosine times cosine over sine. So here we go. I've got sine theta over 1 plus cosine theta over 1 times cosine theta over sine. All right. Got sine theta over 1 plus cosine squared theta. Right to left, left to right gives me sine squared theta plus cosine squared theta over sine theta. Sine squared plus cosine squared is 1, and 1 over sine theta is cosecant theta. Hopefully this is getting a little easier for you and you're starting to recognize that you can move these around in a lot of different ways. All right, let's head to the back. And then we've got 2 rationals. Or maybe not. Maybe I took the rationals out here. All right. Here we go. Cosine over 1 minus sine, cosine over 1 plus sine is 2 over cosine. So we've got right to left, left to right, denominator, denominator. So I've got cosine x times 1 plus sine plus cosine x times 1 minus sine. And all of that is denominator times denominator. So I've got 1 minus sine, 1 plus sine. Okay. Let's go ahead and distribute, because first I'm trying to get rid of all the sine values and I got to figure out how to do that. So I'm going to have cosine x plus cosine sine plus, here we go, cosine x minus cosine sine. And then in the denominator, it's difference of squares. I've got 1 minus sine squared x. And you know where that's heading, or you should. So in my numerator, this goes away and that goes away. Do we agree? And so now I've got 2 cosine x, and 1 minus sine squared x is cosine squared x. The cosines are going to cross out, and we've got 2 over cosine x. All right, take just a minute and work problem 8. And again, your radar should be up, because you've got cosecant squared and you have 1 minus cotangent squared. Granddaddy, granddaddy, granddaddy. Be thinking about that. I'll put the answer up in just a minute. Okay, so before I jump into this one, I'm going to ask you, of course, we're working with the third variation of the granddaddy equation. And you have in the problem 1 minus cotangent squared theta. So can I replace that with cosecant squared theta? And the answer clearly is going to be no. I can do cotangent minus cosecant as -1, or I can do cosecant squared minus 1 is cotangent squared, but I can't change cotangent squared plus 1 into 1 minus cotangent squared. So my other option is to look at the other side of the problem and say, hey, I've got 2 minus cosecant squared theta. Well, cosecant squared theta is cotangent squared theta plus 1. So that is what I did. So now I've got 2 minus cotangent squared theta plus 1. I'm going to distribute the -1. So I've got 2 minus cotangent theta minus 1, which of course is 1 minus cotangent squared theta. Okay, let's look at problem 9 together. Sine plus cosine squared times tan is tan plus 2 sine squared. All right. We're going to be working on the left side of the problem and trying to make it look like the right side of the problem. So again, even if you don't know where to go, just start mathing. Let's just start squaring sine plus cosine. So I have sine x plus cosine x times sine x plus cosine x times tan x. That's where this pen's not showing up very well. I'm going to shift colors. All right, so let's do what they say. So I've got sine squared x plus 2 sine cosine plus cosine squared x all times tan x. Okay. Well, again, Granddaddy jumps in because sine squared plus cosine squared is 1. So I've got 1 plus 2 sine cosine times tan. I'm just going to move it to the front because it's easier to see for distributing. So here we go. We have tan x plus 2 sine x cosine x tan x. Okay, so look where you're heading. You want tan plus 2. You got the tan, and there's the 2. So somehow sine cosine tangent turns into sine squared. And it's not hard to find out how. We're just going to change some identities. And once you change that tangent identity, this goes away and sine times sine. So now you've got your answer, tan x plus 2 sine squared x. And that is that. Okay, we're going to move into the review. And then, like I said, I'll send the test out. And then I'll send the key to the test out later so you can check your work and let me know how you did. Okay, 1 through 15, just ask us to simplify. Well, hold on a second. Let's get our granddaddy. Okay. All right, what's 1 over cosecant? It's just sine. Sine cosine over 1 minus cosine squared. Well, 1 minus, I'm sorry, I wrote cotangent instead of cosine up here. I beg your pardon. So 1 minus cosine squared is sine squared. So we have sine cosine over sine squared. Do we agree? The sines are going to cancel out, so I'm left with cosine over sine, or simply cotangent x. Number 3 is a little more challenging. You have 1 plus sine squared over cosine squared. Now, you may want to turn those into rationals, or sine squared over cosine squared is tangent, and 1 plus tangent squared is secant squared. That's a 2. All right, problem 4. The square root of tangent squared plus 1. Well, tangent squared plus 1 is secant squared, and the square root of secant squared is simply secant x. So for 5, work out 5 real quick. And hopefully you ended up with cosine x. All right. Cosine times secant, easy. 1. Number 7, work that one out real quick. Hopefully you end up with 1. Number 8, 1 minus 1 over cosecant squared. Well, 1 over cosecant squared is sine squared, and 1 minus sine squared x is cosine squared x. Tangent times cosine, sine x. Because tangent is sine over cosine, and cosine over 1, boom, boom, there you go. Cosine squared minus 1, this is one you have to be careful about. You're moving the 1 to the left, and you're moving the sine to the right, so we end up with negative sine squared x. You don't know identities yet. We haven't talked about that, so you're not going to be responsible for 11 and 12. We'll talk about identities when we get back together. Tan squared x over secant x plus 1 plus 1. Well, I know tan squared x is what? Secant squared x minus 1 over secant x plus 1, and it all plus 1. Okay, well, difference of squares. So now we have secant x plus 1, secant x minus 1 over secant x plus 1 plus 1. You've got secant x minus 1 plus 1, or simply secant x. Okay. All right, 14. Again, here's those alarm bells. Secant squared x minus 1. Well, clearly that is tan squared x. So I've got tan over secant squared x. So now I'm going to what? Change their identities. So I have sine squared over cosine squared divided by 1 over cosine squared. That's secant, isn't it? When you flip it to multiply, you're going to have sine squared x. All right, try 15. I'll put the answer up for you in just a second. Okay, hopefully for 15, you got an answer of 1. Okay, if you didn't, let's see what's going on here. So I've got cosecant, which is 1 over sine, minus cotangent, cosine over sine, over tangent, sine over cosine. I'm going to flip and multiply, so I have 1 over sine times 1 over sine, minus cosine sine times cosine sine. So all I've done is flip and multiply, which is going to give me what? 1 over sine squared minus cosine squared over sine squared. Well, now I've got a common denominator, so I can put these fractions together, and I have 1 minus cosine squared over sine squared. Using the granddaddy identity, 1 minus cosine squared is sine squared over sine squared is 1. There you go. Let's go on to the back. Now we've got, hold on a second. We've got cosine over 1 plus sine plus 1 plus sine over cosine. And we're supposed to make that look like 2 secant theta. All right, right to left, left to right, denominator, denominator. Again, even if you're really not sure what to do, you know how to handle rationals, so just start mathing. Let's go. So I've got cosine squared theta plus, when I multiply 1 plus 1 plus sine, I've got 1 plus 2 sine theta plus sine squared theta. And all of that, excuse me, is over 1 plus sine theta cosine theta. Well, again, you should be able to see the cosine squared plus sine squared is 1, right? So now I've got 1 plus 2 sine theta over 1 plus sine theta times cosine theta. So that's going to give me 2 plus 2 sine theta over 1 plus sine theta cosine theta. What can I do in the numerator? Well, of course, we can factor out the 2. And once we do that, we can get rid of that common factor, leaving us 2 over cosine, which of course is 2 secant theta. Okay. Verify the following. I think this is probably the last problem we're going to be able to work due to our time. So here we go. You have an example of 23 in your notes, so you can just go back to that. So secant plus cosecant over 1 plus tan, right? So I've got 1 over cosine plus 1 over sine, which is going to give me sine x plus cosine x over cosine sine. That's my numerator. And in my denominator, since this is all sine cosine, I'm going to change this to 1 over 1 plus sine x over cosine x, which is going to give me right to left, left to right, cosine x plus sine x over cosine x. Right? We're going to flip it, and we're going to multiply. So I've got cosine x over cosine plus sine. Those are going to cancel out, and I'm left with 1 over sine, which is cosecant. Okay, so that's what we have time for today. I'm going to send out a quiz with the key immediately, because it's just for practice. And then I'm going to send out the test, and I'll send the key to the test next week, and you can see how you did. It's all identities, of course, with some review material in there. And then, if I'm not mistaken, we probably have 3 or 4 more lessons after that, and we're going to try to get them in as quickly as possible so you can watch them when it's available and convenient for you. Okay, thanks you guys. Have a great day. Talk to you next week.